Okay, I've just turned the camera on. So again, we have 3 points. And we want to find the equation of the quadratic function. This topic always chokes me up. The quadratic function whose graph passes through those 3 data points. There is a unique quadratic function through any 3 data points, as long as they don't have the same x-coordinate, because of course then you wouldn't have a function. You'd fail the vertical line test. So it might, the graph of that function might look something like this. Okay, so whatever the function is, any quadratic function has the form ax squared plus bx plus c. Okay, well, let's just give these points coordinates. I was going to use symbols, but I think I'll just use coordinates. Let's say this is 1, 3, and this is 4, 7, and this is 8, put the parenthesis to the left of the number, 6. Okay? Whatever the numbers are, it's very easy to do this. So then, okay, first point, 1, 3 means, of course, that x is 1, when x is 1, y is 3. So we plug in 3 for y, we get 3 equals ax squared. Well, x is 1, so x squared is 1. Bx is also going to be 1, and c is always just c. Then the point 4, 7 tells us that 7 equals 16a, because of course x is 4, and x squared is then 16, so we get 16a plus 4b plus c. Then the point 8, 6 tells us that 8 equals 64a, 6 equals 64a, plus 8b plus c. So, writing this all as a matrix equation, we get 16, 4, 1. Well, I wrote the second equation first, but I can do that. 1, 1, 1. 64, 8, 1. Times ABC equals 3, 7, 6. We can verify that this matrix is invertible. It'll always be invertible if you have points with distinct x-coordinates. So, you can solve by inverting your matrix, and you know perfectly well how to do that. Or you can write down an augmented matrix and solve by row reduction. Once you solve, you have your values of a, b, and c, you plug them in, and you have your function. So it's very straightforward, but that's a really big deal. Now you can also do this if you have 4 points. Now, you're not going to get a quadratic function through these 4 points. So the quadratic function that works for these 3 is not going to work for this. Quadratic function that works for these 3 is not going to work for this. So any 3 you pick, the quadratic function that you get for those 3 points is not going to work for the 4th point. However, we can do a cubic polynomial. So there is a cubic polynomial whose graph fits this. And if you remember pre-calculus, or calculus especially, you remember that a cubic polynomial, you're going to have a quadratic derivative, and you solve that quadratic derivative equal to 0, giving you the turning points. You might not have any, but you can solve it and find out. So it might give you a function of this nature. Okay, now I kind of missed those points when I drew the curve, but that's to be expected this time of the afternoon. Okay, so we have this curve. Well, we'll do ax cubed plus bx squared plus cx plus d. And you get, now something just flipped here, so I don't know if Zoom just abandoned me or what. Okay, Zoom just flipped out. And now it's asking me something it shouldn't be asking me. So I don't know if we're going to be able to continue this class or not. But I'm going to close Zoom. Let's get rid of it. And start over. And hopefully be able to continue the video.